The title of experiment number 2, it is the verification of Kirchhoff's law. So part 1 of our experiment, it is the setup diagram of the verification of KCL. So it is stated here in our schematic diagram. Take note that this is the schematic diagram and we will perform now the wiring connection. So, stated in the schematic diagram that we have a 2 power supply, DC power supply. This is our voltage DC 1, this is our power supply 2. And then we have the equivalent, so since this is analog, this is also a digital reading. And then we have ammeter 1, this is ammeter 1 or I1, I2, and I3. So we will perform now the experiment based on the schematic diagram, and also we have a resistor box. It composed of 100 ohms, 330 ohms, and 1000 ohms. So we will start our wiring connection by considering or by the use of schematic diagram. So there is a polarity. Take note for the polarity, the power supply positive will go to R1, input of R1. So meaning we have the power supply to R1. So this is the R1, and then the R1, and then the output of R1 will be connected to positive of ammeter 1. So ammeter. So from the output of R1, we will connect to positive polarity of ammeter 1. And then the negative polarity or negative of ammeter 1 and negative of ammeter 2 are connected together. So it means the common terminal for ammeter 1 and 2 will connect together. We will connect it together. Same common. Then, from the common connection also, from common, we will connect to the positive polarity of ammeter 3. So this is now the common of ammeter 1 and 2. We will join together and then connect to the positive polarity of ammeter 3. Okay, so ammeter 1, ammeter 2, and ammeter 3. Okay. Now, the positive polarity of the ammeter 2, we will connect it again to resistor 2. So, from the positive of ammeter 2, we will connect to R2. And then the output of R2, we will connect to the positive polarity of our power supply number 2. Then, as you've noticed, stated in the schematic diagram that both negative of the power supply we will join together. So, both negative of the power supply we will join together. Then, the common of ammeter 3, so we are now in ammeter 3. So this is the ammeter 3 common or negative polarity. We will connect to resistor 3. Resistor 3, which is 1000 ohms. And then the output of resistor 3, we will join to the common or the negative polarity of the power supply. Then, we will connect now our monitor for our voltage input. So, this is our battery or supply, the positive and then the negative. Then the other side also, we need to monitor also in digital reading. This is for digital reading for our voltage. We have analog and we have a digital. So this is the actual connection. This is a wiring diagram, a wiring connection rather, and this is the schematic diagram. So you just follow what is stated in the schematic diagram. So from schematic diagram, it will follow with the wiring connections. Now we will turn on the component and materials needed in this experiment. So in the table, so write the measured current and voltage data. So we will focus on the current. So it is given here that the voltage of power supply 1 and the voltage of power supply 2 will be the same at 15 volts. So we will 15 volts for power supply 1. Okay. And then another 15 volts for power supply 2. Okay. So now, this is our by inspection. As I told you before in the previous experiment, before you write or take the reading, you will inspect if your wiring or the output current is correct or not. So by adding the current of I1 plus I2, it is equal to I3. So the current 1 of ammeter 1, it is 9.8 milliampere, and then plus the current reading of ammeter 2 should be equal to ammeter 3. So we will record now the reading. So the current of I1 across R1 or I1, we have the I1 reading. Okay, so we have the I1. Okay, I1 as 9.6 milliampere. So it is I1 9.6 milliampere. And then I2, it is 3.9 milliampere. So 3.9 milliampere. And then the current of I3 is 13.7 milliampere. 13.7 milliampere. So, at node 1, it means from this node, from node 1, what is the equivalent for our I1? So, just substitute the I1, which is 9.6 milliampere plus I2 3.9 milliampere. So you just add 3.9 milliampere equal to 13.5 milliampere. So the calculated value is 13.5 milliampere and the measured value is 13.7 milliampere. So, at node 2, what is our I3? So, I3, we have 13.7 milliampere equal to I1, also equal to I1, which is 9.6 milliampere plus 3.9. So, it is the same. So, node 1 and node 2. Now, we will proceed to second reading. So, first thing to do, for safety purposes, you need to turn off both power supply. So, take note that in reading number 2, we will open it to 15 volts. So we have already in 15 volts. So now we will adjust the power supply 2 into equivalent of 5 volts. 5 volts only. Okay, so as you've noticed, we cannot locate the exact 5 volts for this because of the supply coming from power supply 2. You need to turn off the power supply here for you to enable you to get the exact 5 volts here. So I repeat, before you get the 5 volts here, make sure that the power supply 2 should be in off condition. Okay, so we will now on the power supply 1 and likewise the power supply 2 also. So we will on. So it is 15 volts. So it is now 15 volts and here it is also 5 volts. So if you will see it again, I repeat so that you will not confuse. When I turn off here, so you will measure 15 volts here. And then when we will turn off here, we will measure 5 volts here. When we will turn on both power supply, you will observe this is 15, this is become 11.5 because it is overlapping the voltage, the higher voltage going to the lower voltage. But it is not the issue in our, it is not a big issue in our experiment, which is KCL, because we are focusing on the current. Now, by inspection again, as I told you, by inspection, you will see immediately if your connection is correct or not. So, take note that this is our I3, this is our I1, and this is our I2. 17.6 milliampere minus 4.8 milliampere, it is equal to 12.9 milliampere. So, meaning, our connection is correct. So, we will continue the reading. So, we will hold now the ammeter. So, our I1 is 17.7 milliampere. And then, our I2 is minus. Take note for the negative sign. Minus 4.8 milliampere. And then, I3, we have 12.9 milliampere. So, we will substitute now to the given node equation. I1, we have 17.7 milliampere plus minus 4.8. So it is 12.9 milliampere. So it is the same with the current through I3. And then also, I3 should be equal to, if you will add the I1 and I2, for the I3 should be the same also. Then, we will now proceed to next reading. Okay, next reading, we will turn off again both power supply. So, we will focus on the input of 5 volts. The supply of the voltage supply for power supply 1 is 5 volts. 5 volts. Okay. Then turn off here, and then we will turn on off the power supply 2. So, adjust to 15 volts. Okay. Now, both power supply, we will open both power supply and then remove the whole control. So by inspection again, you will see the reading. Current ammeter 1, negative 4.2 milliampere. And then in ammeter 2, 14.8 milliampere. And then in I3, we have 10.3 milliampere. So, by inspection again, we will get the value of this by subtracting because we are using now at node 2, the I2 minus the I1 should be equal to I3. Now, we will write now the value for our I1 minus 4.2 milliampere. And then I2, we have 14.8 milliampere. And then I3, you have 10.3 milliampere. So substituting from the equation, so you will see what is I3? What is I3? It is the same, right? It is 10.3 milliampere. So the answer here should be 10.3 milliampere. Okay, 10.6 here. Okay, 10.6 milliampere. And then at node 2, it is also the same. 10 point, okay, it is 10.6 milliampere. So, what is the remarks of this? From KCL, from node 1. So, take note that the node 1, it's stated here. This is our node 1 and this is the node 2. So, what is your remarks here? Just, since we proved it already that the current 1 plus current 2 is equal to, it is equal to current 3. So, the measured value and calculated value are the same. Okay, value are the same. So, the same with the node 2. So, this is now the experiment number 2 and the part 1 of experiment number 2, which is the KCL. Okay, so